So, in our last explainer, we talked about how code gets built into a program, kind of like constructing a digital building. But that left us with some pretty big questions, right? Once that building is up and running, who actually gives it the land, the RAM, to exist on? Who's in charge of supplying the electricity from the power plant, the CPU? And maybe most importantly, who stops all these different buildings in our digital city from just crashing into each other? Well, today we're going to meet the master planner, this powerful and honestly invisible mayor of our digital world, the operating system, or OS. Here's the big idea. Imagine your computer is a bustling city. The hardware, your CPU, your RAM, your hard drive, that's all the city's raw resources. Your apps, they're the buildings, the shops, the businesses. And the OS? It's the entire government running the whole show from behind the scenes. So, what does this mayor actually do all day? Well, it has a few absolutely critical duties that keep the whole city from just grinding to a halt. At its core, the operating system is the master software. It's the foundational layer that sits right between all your apps, the businesses, and all the hardware, the city's physical infrastructure. And its job is to make sure they can all work together without causing total chaos.
Now, its job is super complex, but to keep things simple, we can really boil it down to two main things. First, managing all the city's resources, and second, keeping everybody safe by controlling who gets access to what.
First up, resource management. Okay, so when you launch an app, it's basically like a company going to the mayor and saying, hey, I need a plot of land to build on. The OS, acting like a city planner, looks for an empty plot, that's a piece of your RAM, and ropes it off just for that app. It makes sure no other app can build there. And then, when you close the app, the OS reclaims that land, making it available for the next business that comes along. But what about power? The city's main power plant, the CPU, can really only power one building at a time. So how in the world are you listening to music while you're also browsing the web? The secret is that the OS is an unbelievably fast traffic controller. It switches the main power line between all your open apps millions of times every single second. A tiny slice of power for your browser, then a tiny slice for your music player, then back again. It happens so incredibly fast that it creates this perfect illusion that everything is running all at once. That's the magic of the OS. Now, the mayor's second huge job is security. An app can't just decide to turn on your webcam. I mean, that would be like a random company just starting to dig up a city street without any permission. No way. Instead, that app has to submit a formal request for a permit. It's something called a system call. And only if the mayor, the OS, approves it, will it send its own specialized, trusted city work crews, we call them drivers, to handle the hardware. This ensures the job gets done safely without wrecking the city's infrastructure.
Okay, so we get what the mayor does. But how do we, the citizens, actually communicate with City Hall? How do we tell the OS what we want it to do?
Well, there are two main ways. The first is what's called the command line interface, or CLI. You can think of this like filling out a very precise text-only government form. It's incredibly powerful if you know the exact specific language to use, but yeah, it's not super friendly for most people. The second way, and the one most of us use, is the graphical user interface, or GUI. This is your desktop, your icons, your mouse pointer. It's like walking up to a friendly information desk at City Hall and just pointing to what you want on a map. It's intuitive, it's visual, and it's just plain easier for everyday tasks.
Right, and just like in the real world, not all mayors govern the same way. Different operating systems have completely different philosophies, and that leads to some very different kinds of cities.
You've definitely heard of the three main mayors running the show. You've got Windows, which is like a sprawling commercial megalopolis. Then there's macOS, which is more like a pristine and exclusive garden city. And finally, you have Linux, which isn't really a single city at all, but more like a vast federation of do-it-yourself communities. So let's break it down. Windows is that massive commercial hub, kind of like New York. It's built to be compatible with almost any kind of business or building you can imagine. The downside? Its huge size and secret city plans make it a much bigger target for crime, like viruses. Then you have macOS. Think of it as a beautiful, exclusive, gated community. Apple designs the city, the houses, everything. It's all harmonious and super secure, but it's expensive to get in, and the rules are very strict. It only runs on Apple's own hardware. And then there's Linux. It isn't one city, it's an open source blueprint. Anyone can take it and build their own custom city. This gives you the ultimate freedom, and it's exactly why Linux is the invisible backbone that runs most of the internet. So when you put all of this together, you start to realize something pretty amazing. The OS isn't just another program on your computer. It's the unsung hero that makes everything else even possible. From managing your memory and power, to keeping you secure, to giving you the very windows and icons you click on every day, the operating system is the silent, hardworking, foundational layer of your entire digital life. It's the mayor we never actually see, but one we absolutely could not live without. But hang on, there is one last piece to this puzzle. We talked about how the mayor manages temporary land, the RAM. But what about the city's permanent library, its historical archives? Your hard drive. How does the OS file away millions and millions of documents so that any one of them can be found in a split second? Well, that's a job for something called the file system, and that is exactly what we'll explore in our next explainer. Until then, stay curious.